In this tutorial video we will be learning about basic operations in Blueqat. We will be doing this in Google Colab. Like we did in previous video, we will start with installation of Blueqat. We can do it by using this code !pip install Blueqat. Type the code that was shown earlier in Google Colab. Then click on play button and Blueqat will be installed. Basic operations. Learn the basic states and gates of PhotonCat's Fockbase. Gaussian base does the same thing, except that some of the features of Fockbase are not available. Gaussian base is faster and more accurate than Fockbase because the backend processing is different. First, we have to import libraries. Copy the code that is on the screen and click on the play button. I have already installed it, so it is showing requirements already satisfy. Again, we have to import some libraries. After this, copy the code that is on the screen and click on the play button. Photon number state, Fock state. Ket psi equals alpha 0 times ket 0 plus alpha 1 times ket 1 plus alpha 2 times ket 2 plus so on. Bracket nm equals delta nm. Sum of k modulus alpha k, whole square equals 1. You can prepare any ket n state with the n-photon, mode, photon num, method. The initial state is ket 0. Now copy the code and click on the play button. It will print the photon number state. Wigner function. In addition to representing the quantum state of light in terms of photon number states, it can also be plotted as a function on the q-p phase plane using the Wigner function. F, Wigner, mode, plot equals, y or in, x range equals 5 ponit 0, range equals 5.0. The photon number states can be written in density operator notation p equals sum nn. Cnn, ket times n times, bra n dash, and for p equals ket n dash bra n regarding the formula given below. For each q, p, and plot it. The function plotted here represents the probability of measuring a quantum state at position q, or momentum p. Displacement gate. D alpha equals exp times alpha hat alpha dagger minus alpha asterisk alpha dagger. Translate the state on the q-p phase plane by re times alpha im times alpha. Now copy the code and click on the play button. It will plot the Wigner function. Squeezing gate. S epsilon equals exp 1 by 2 epsilon asterisk a square minus 1 by 2 epsilon a to the power dagger 2. Epsilon equals r times e to the power 2 I phi. Normal ordered form. This is the normal ordered form. Squeeze the state on the q-p phase plane. The parameter phi indicates the direction of the squeeze, and the larger the parameter r, the stronger the squeeze. When the distribution is narrowed by squeezing in a certain direction, the distribution widens in the opposite direction orthogonal to it. Here we have given different parameters than displacement gate. Now copy the code and click on the play button. It will also plot the Wigner function. Beam splitter. Beam splitter Hamiltonian, hat h equals ih bar theta, times, a1 to the power dagger times hat a2, minus hat a1 times a2 to the power dagger. Bs gate equals exp I by h bar times hat h. A device called a beam splitter mixes the light in the two modes. A beam splitter is an element that reflects r% of the incoming light and transmits t% r plus t equals 100, like a mirror that transmits a certain amount of light. Now copy the code. It is a 50-50 beam splitter. And we are also sampling the number of photons in mode 0 50 times. It will print home interferometer as, when two single photon modes are input to a beam splitter, the number of photons in the output mode will always be 2 in one mode and 0 in the other. However, it is written in Japanese. Kerr gate. Kerr Hamiltonian h equals h bar percent by 2 times a to the power dagger, whole square times a square. Then k is equal to the formula given. In some optical media, the refractive index depends on the intensity of the light, a phenomenon called the Kerr effect. On the phase plane, the phase rotates at different angles depending on the distance from the center, intensity. The Kerr gate is a kind of what is called a nonlinear gate. It is said that at least one type of nonlinear gate is required to perform universal calculations in continuous quantity quantum calculations. Now copy the code and click on the play button. It will plot the Wigner function with Clenshaw method. That's all for today. Thank you.